based on the idea in business that if you start a business, your cost equation is maybe going to, if it's kind of an ideal situation, it might look something like this, where this is your cost, C of X, and that's equal to the cost per unit or thousands of units or something like that. And the reason that your cost equation looks kind of like that, and I had to look in the book and see why it looks kind of like that, is because maybe when you start a business or something, your costs initially are very high because you got to get all the startup stuff going and everything. And then as you get going, those costs are still increasing. Maybe as you're selling more, your costs are going up, but maybe at a lower rate. And then maybe at this point, maybe it starts going up again because why? Maybe because the market becomes saturated with your product, or maybe your employees have been working there a long time and they want to get a higher wage. They want to try to get a higher wage, so you have to give them a raise, or they say, oh, we want health insurance. And you say, don't worry about that, you can have Obamacare. Okay, so anyway, I'm not making any political allusions or anything. So anyway, so at some point, kind of goes up and then it goes down. Then you have a profit, or not a revenue equation, and at the beginning, your revenue, you're not making any money, and then maybe the revenue is going up very fast, and then maybe the revenue goes up kind of slower after the market gets saturated. So revenue is not like your profit. Revenue is how much money you take in, okay? And at some point, so if this is your revenue equation, R of X, and so RC, not RC, R of X. Sorry. This is R of X for how much money you take in. And at 2 points in here, this point and this point, when these two lines are the furthest apart, okay, this represents what? When these two lines, if this is your money you're taking in, and this is the money you're paying out, okay, when this distance is at its greatest difference, right, that's going to be your maximum profit is going to occur right there. Your maximum profit is going to happen right there, okay? Yes?
Don't tell me that's a point of inflection.
What? No, it's not a point of inflection. It's when the
oh, that's revenue on the I mixed up the
yeah, because revenue started off, you're not making much money, right? But then you start making more money, and then maybe people kind of like, you start Chipotle, at first you don't make any money, right? Then you start making, money really fast because people go, oh, Chipotle, that's the greatest place. And then after a while, other places pop up, the market starts saturating, and you don't make as much money or something like that, okay? Then over here, what does this represent? What does that point represent?
Oh, I thought that graph was cosine t.
Oh, I see. Cost. Oh, very good.
I was like, wait, that does not look like a cosine.
Okay. Oh, cost. Very good. Okay. What does this represent? Yeah, so this is your maximum cost or minimum profit, maybe? Minimum profit, okay? And so this is X, and this is dollars, I guess. And this X is usually in thousands of units or something like that. Maybe you're selling burritos or coffee at Starbucks.
Oh, it's not about time?
No, it's not about time. It's about how many units you're selling, right? And
we should make a burrito startup at Monarch and do a real-life experiment on
calculus. Oh, that's a good idea.
And then we all get A's.
Okay, let me finish. Okay? So anyway, it turns out that the profit P of X is equal to your R of X. I think they use little r, okay? Minus C of X. Does that make sense to everyone? your profit is equal to your revenue minus your cost. And so if your revenue is below your cost, that number is going to be negative. And if it doesn't start changing, you're going to go out of business, you know. Okay. The other thing that they say is that when, they talk about these things called marginals, okay? So dr dx is called the marginal revenue. Marginal revenue. And so basically that's the slope of your curve, right? But it also, they say physically what that represents, if you're finding the marginal revenue at a point, okay, what that represents, they say, is the cost of producing one more unit. The cost per unit of producing one more unit, it's the slope of the line, okay? So just dr dx is the marginal revenue. dc dx is called the marginal cost. Marginal cost. And dp dx is called the marginal profit, okay? And I would guess that you want your marginal profits to be big, right? And your marginal costs to be small, yes? And
So, Mr. Leader, the dr/dx is a marginal revenue. That's the slope of the revenue line.
yes, that's the slope of the revenue line.
What's the least?
At any point. So it's the marginal revenue at any point. So you would want this thing to be going up, right? And the other one to be going down, you would want, right? But what happens is when those two things are equal, when the marginal revenue is equal to the marginal cost, that's where you find your maximum profit. Because if you think about it, right, this one's going uphill, and you want this one to be sloping down, right? Or it's going up, but maybe you want their rates to, when this changes from decreasing to increasing, I guess, okay? Anyway, when those two things are equal, okay? Yeah, they're both increasing, but their rates of increasing are changing at that point. Does that?
Yeah, the
Yeah,
same
they're all
slope.
changing.
So when you find them,
They're either a maximum
Yeah, I guess so. Well, just worry about this, okay? That when dr dx is equal to dc dx, okay, that's where you're going to have your maximum profit, okay? But also over here, you're also going to have your maximum loss, right? So you want to make sure that you're at the profit part and your loss part. What's this part? What does that part represent? What does that point right there represent? That's your break-even point, right? There's your break-even. So anything after this point, you're good, right?
unless you start.
Unless at some point, and they do say in the book that at some point they do cross again, and that's bad because maybe, maybe someone gets sick from eating your burritos or something, or maybe, or they get sued, or maybe the employees demand higher wages or something like that, or all kinds of unforeseen, things as you go through. Okay. So anyway, let's do a problem. So suppose, and this is just, I stole this from the r of x equals 9x. 9 is no longer, and c of x equals x cubed minus 6x squared plus 15x. And I know that, like when I taught Cal KB, I didn't see much of this, but then my friend's daughter goes to CU and she's in the business school, and I was tutoring her in business calculus. And that's when I saw all this stuff, because they really emphasize this stuff in business school and stuff. So it is important, okay? Find the value of x that maximizes the profit, okay? optimizes profit. And so all you have to do is take the derivative of this, which is r prime of x. R prime of x equals 9, and c prime of x is equal to 3x squared minus 12x plus 15. And you set those two equations equal to each other, because that's where the marginal cost is equal to the marginal revenue. And that would give you your maximum profit. So you're going to go 3x squared minus 12x plus 15 equals 9. So 3x squared minus 12x plus 6, right? 6 equals 0. And then unfortunately, if this could factor, does it factor? I could pull out a 3 out of there, couldn't I? Did I do that? I think. So I get x squared minus 4x plus 2.
X minus 2, X minus 2. Or no?
It doesn't factor, okay? Doesn't factor, so you do have to plug into the quadratic formula, and with the quadratic formula, with the quadratic formula, with quad formula, you get x is about equal to 0.586, 3 decimal places, 0.586, or 3.414. Oh look, it looks like pi, doesn't it?
It does.
3.414. But I think that's just coincidence. Yeah, it's not pi. So which one of these do you think would be the maximum profit? The first one or the second one? Probably the second one, because if it were kind of like that graph that I showed you back here, right? The first one represents your minimum profit or your maximum loss, and this one represents your maximum profit. In case you didn't know that, the last class asked me to check, and how would I check that? Well, I would take my revenue equation minus my cost equation. I could just plug in both of those numbers into the revenue and cost and see that the cost or the revenue exceeds the cost at that point. I could subtract that. Oh, or I could just plug this. Yeah, I could plug into here and then plug into here and see that this number would be bigger than this number, right? And the other thing I could do is I could come up with a profit equation. P of x is equal to my revenue equation minus this. So what that would look like is minus x cubed. There's no x squared over here. Minus 6x squared. 9x minus 15x makes minus 6x. Is that right? Minus 6x? Minus 6x. Do you guys see what I did?
How do you get the negative x cubed?
Because I want to subtract revenue minus cost, okay, to find my profit. And so the profit equation is r of x minus c of x, right? And if I do that, that's what I would get. And if I take the derivative of that, p prime of x, I get negative 3x squared minus 12x minus 6. And then if I take this number and plug it in here, I should get out a negative number. And if I plug this and plug it in, I should get out a positive number. Or, better yet, hold on, I could take this second derivative, p prime, and that's equal to negative 6x minus 12. And then if I plug in 0.586 in here, it can be seen that this is going to give you a negative number. And if I plug in 3.4, I'm also going to get a negative number. Wait a minute.
Yeah, it's always negative.
Where did you get that?
It's always negative. That's good. because that means, wait a minute.
Unless you put a negative X.
Hey, Mr. Leader, where did you get that profit from?
I took this and I subtracted this.
So shouldn't it be plus 6x?
What?
Oh, thank you.
No, not that one.
Where?
Just in the
Why is it
profit.
negative 6?
Thank you, that's where I messed up. Okay?
That's
Why
not
is it changing this?
That should be a plus.
Why that first one negative?
That's right. 9, so if I subtract this equation minus this equation, 9x, so I subtract, so
Oh,
this
yeah.
becomes negative,
Oh.
this becomes positive, right? And this becomes 9x minus 15, that's where I messed up. That becomes negative, okay? So then when I take the derivative, that becomes plus 12, right? And that becomes plus 12x, right? And then if I plug in, that makes sense. If I plug in 0.586 in here, I get out a positive, wait, 0.586
Yeah.
in here, I get out a positive number, which means my graph is concave up, which means I'm at a minimum, right? And then if I plug in 3.414 in here, I get out a negative number, which means I'm concave down, which means I'm at a maximum profit, okay? So it's just a simple error, I think. But I don't think you have to do that on this one, because you could just assume that the curves kind of go like that and like that respectively, you know? Okay, but I think it's a good idea, okay? And then the next thing they talk about, and this is, I only give you 2 problems in your homework like this, so the next thing, that's,
So you get 2 problems.
no, but there's about, so I assigned 2 problems plus 6 more from the optimization. So all I gave you is 8 problems. And so the next thing is minimize, so another way to maximize your profits, maximize your profits. This is what profits by minimizing your costs, by minimizing minimizing the average cost. Average cost. So one way you can minimize your average cost is by importing your products from a third world country. So you should do that. No, just kidding. Minimize your average cost. But really, that's what they, like.
About that child labor.
Cutting
regulations.
Actually, why China?
So here we go. I want to move on. So the production level, at which the average cost is at a minimum is smallest is a level at which the average cost is equal to the marginal cost. Okay? So what the heck does that mean? It's kind of like it is actually an application of the mean value theorem. All right. So if you have a cost equation, and so your costs are initially high, and then they slow down, and then your costs increase, or something like that, your average costs, okay, would be represented by a line, the slope of this secant line. Do you understand that? That's your average cost, okay? And then what they say is that your average cost, your production level, your profit is minimized at either this point here, okay, at the tangent line there, or at the tangent line there. So when the slope of the tangent line is equal to the slope of the secant line of your cost equation, then that's when your the cost is the lowest, all right? So it's got to be either here or here, but I think it would probably be this one, right? Okay. And so probably you're going to look for the second one. And the way you would find, so say for example, that you have a cost, I'm learning a lot about business as I teach this stuff, okay? So say you have a C of x equation given by, and apparently these can be modeled pretty well with cubic functions. 3x squared minus 12x plus 15x. So here's your cost equation. I'm not sure how they come up with those, but apparently you, whoops, that's the wrong one. Sorry. No, that's right. X cubed.
Plus 3x.
I messed up. Sorry, I messed up. Cost equation is a cubic equation, and it comes out to be, the one they give you is x cubed minus 6x squared plus 15x. And so the average cost is going to be the cost at any point divided by x, right? Because if you take the cost at some point and divide by, if C of 0 is 0, right, and C of x is something else, if the bottom, this length is going to be x, right? So to find the slope of that line, I do like this. So C of x can be found by dividing this, the average cost. Average cost can be found by dividing the cost equation by x. X cubed minus 6x squared plus 15x divided by x. And if I do that, I get x squared minus 6x plus 15. Okay? That's your average cost equation. How do I find my marginal cost? Marginal cost, remember, is the derivative of the cost equation. So that's C prime of x, and in this case, that's equal to the derivative of that, which is not the same as this, right? The derivative of that is what? 3x squared minus 12x plus 15. And you set these two things equal, and you solve for x. All right? And so we can do that, right? We get 2x squared. Make sure I do this right. Bring this over here, I get 2x squared. Minus 12x minus plus 6x makes minus 6x. And the 15s go away, right? So I get, when I set that equal to 0, or that's what I get when I set those, when I solve that system, I get 2x squared minus 6x equals 0. And then I can factor out a 2x from both of those, right? 2x times x minus 3 equals 0. So either x equals 0 or x equals 3, right? Yes? Yes? No?
Why does the average cost equal just the cost of the latest expense?
What?
You said this is the cost.
It's the cost per unit. Yeah, so if I sell 1,000 units, the average cost per unit is going to be that, whatever that cost is divided by itself. Yes?
Sorry, I'm just confused about the derivative of C equation from that one and then to the next one.
Because it says, because of this theorem that they give. The production level at which the average cost is smallest is a level at which the average cost, which is this, right? This is the average cost, is equal to the marginal cost, which is this.
Okay, thank you.
Right? And so you set those to equal, and you make sure that this is a minimum and not a maximum. And the way you can do to make sure it's a minimum and not a maximum is to take your average cost equation, take the first derivative, average cost. So C, what would I call it? Cost, average cost equation, average cost, average average cost, and I want to take the derivative of my average cost. So that's going to be average cost prime, average cost prime is equal to 2x minus 6. Average cost double prime, average cost double prime,
Isn't it 4x?
isn't it? No, because this is your average cost equation, right?
Oh, I thought we got
Okay.
together.
Now looking at this, so I want to take the derivative of this because I want to make sure I'm at a maximum and a minimum, not a minimum there, guys. Or my minimum is, right? I'm looking for a minimum. So double prime is 2, which means that it's always positive, which means it's concave up, right? Which means I'm at a what?
You are at
A minimum. So this number 3 is a minimum, right? And so that's, so you want to sell 3,000 units. If it's 1,000 units, to minimize your cost. All right. So your homework is on my website. You want me to write it down? Okay. It's page.
Wait, it's only 2 problems.
No, the first 231, 23 and 25 are on this stuff, and there are only a few problems, and the rest is just practice on optimization. 20, 21, 37, and okay? Okay. Stop.